We have seen how we can use two half equations to produce the full ionic equation for a redox reaction. We will now look at working out the full ionic equation for a redox reaction from oxidation numbers. Suppose we are told that hydrogen sulfide, H2S, reacts with nitric acid, HNO3, and sulfur and nitrogen monoxide are two of the products. We first write down what we know in the form of an equation. We don't worry about the fact the equation isn't balanced at this stage. We need to establish which species have been oxidized and which reduced by working out the oxidation numbers. We will remind ourselves about the rules for oxidation numbers as we go. For hydrogen sulfide we have hydrogen, and hydrogen, when not part of a metal hydride, has an oxidation number of +1. The total for the oxidation numbers equals the overall charge, and since hydrogen sulfide is a neutral molecule, the oxidation numbers must total 0, and consequently sulfur has an oxidation number of -2 in H2S. With HNO3, hydrogen is +1, the oxygen is always -2, except in peroxide compounds, and the overall charge, because it is a neutral molecule, is 0. And so the oxidation numbers total 0. The nitrogen must therefore be +5. The sulfur, being an uncombined element, has an oxidation number of 0. For the nitrogen in nitrogen monoxide, the oxygen is -2. The total for the oxidation numbers is 0, and so the nitrogen has an oxidation number of +2. We can now see that the nitrogen has been reduced as the oxidation number has decreased from +5 to +2, which is a change of -3. The sulfur has been oxidized as its oxidation number has increased from -2 to 0. This is a change of +2. When we worked with half equations, we needed to adjust the molar quantities in the half equations so the number of electrons on each side were the same. Similarly, we need to adjust the molar quantities in this equation so the change in oxidation numbers for the species that have been oxidized and reduced are equal but opposite in value. If we multiply the molar quantities of nitric acid and nitrogen monoxide by 2, and we multiply the oxidation number of nitrogen by the same amount, we will get a total difference in oxidation numbers for nitrogen of -6. If we multiply the hydrogen sulfide and sulfur by 3, this will give a total difference in oxidation numbers of +6. So now the totals of the oxidation numbers for the species that have been oxidized and reduced are equal but opposite in value. We do notice, however, the equation still does not balance. We have 8 hydrogens on the left-hand side and none on the right, and 6 oxygens on the left-hand side and only 2 on the right. So we are 4 oxygens and 8 hydrogens short on the right-hand side. From these we can make 4 molecules of water, and so we can now balance the equation by adding these water molecules. When doing these problems, it is often necessary to add other species to the equation in order to get the equation to balance. If the reaction is carried out under acidic conditions and you are short of hydrogens, you may need to add H+ ions. If the reaction is carried out under alkaline conditions, you may need to add hydroxide ions. With practice, they do become quite easy to do.